Through direct touch, we can perceive the material properties of physical objects. Many researchers have developed various haptic devices for users to feel tactile properties in VR. However, applying these haptic devices in mixed reality, where virtual contents can be overlaid or mounted on physical objects, may not be straightforward. We present ViboPneumo, a vibratory-pneumatic finger-worn haptic device for altering perceived texture roughness in mixed reality. ViboPneumo can provide vibrotactile and pneumatic feedback to increase and reduce the perceived roughness of physical surfaces while preserving other haptic sensations for natural MR experience. ViboPneumo generates vibrotactile stimuli with varying frequencies to increase perceived roughness by capturing real-time velocity of index finger movements, and includes a hollow pneumatic actuator that lifts the fingertip and reduces the contact area between the user's fingerpad and physical surface to decrease perceived roughness. The ViboPneumo system consists of a linear reasoned actuator, a 3D printed housing attached with a hollow pneumatic actuator as the finger-worn part. This is the structure design of ViboPneumo. Here we show the fabricated process of a pneumatic actuator. We first technically evaluated the characteristics of our proposed pneumatic actuator. We first measured the step response of air pressure tracking and maintaining process from 1 to 12 kilopascals based on our closed-loop pneumatic control system. We conducted a numerical simulation to parameterize the inflated displacement of the pneumatic actuator. Then we compared the finger surface contact areas under different air pumping pressure with no air pumping stimuli and calculated the ratio of reduced contact area. We conducted the first user experiment to investigate the texture modulation by ViboPneumo. We included 6 types of materials and 7 types of stimuli, 3 for vibrotactile and 3 for pneumatic stimuli and 1 for no stimuli in our experiment. During texture perception, the participant could move the slider to rate the perceived intensity for 5 dimensions for each material and stimuli. The results showed that the participants could perceive a range of roughness level modulated by ViboPneumo under different stimuli. Additionally, we also observed certain levels of overlapping across different stimuli and materials, potentially modifying the perceived roughness of one type of material towards another. For instance, ceramics could be perceived as smooth as glass by decreasing roughness with ViboPneumo. We also found a similar trend on flatness rating compared to the results of roughness rating, but there was no significant difference among other 3 material properties. Then we further conducted another user study to investigate MR experience with ViboPneumo. We compared 2 modes of objects manipulation, using the bare finger and wearing ViboPneumo with corresponding haptic stimuli for roughness modulation. The results showed that ViboPneumo could significantly improve users' experience of visual-haptic matching experience compared to the bare finger situation. Lastly, based on users' qualitative feedback, we demonstrated more applications using ViboPneumo. Customers can feel textured fabric, for example, feeling the silk shirt texture by touching the denim shirt. Users can alter the texture of the stone on the earth to feel the stone material on the moon through remote touch. Users can also explore the surface texture of a museum artifact inside a glass showcase through ViboPneumo.